Example. Uh, as an example, consider the data on age and earnings in Figure 3.2. For these 200 workers, the sample standard deviation of age is S sub capital A, or S sub big A, equals 9.57 years, and the sample standard deviation of earnings is S sub big E equals $19.93 per hour. The standard covariance, the sample covariance between age and earnings is S sub big A big E equals 91.51. The units are years times dollars per hour, not readily interpretable. Thus, the sample correlation coefficient is R sub big A big E equals 91.51 over open 9.57 times 19.93 close equals 0.48. The correlation of 0.48 means that there is a positive relationship between age and earnings, but as is evident in the scatter plot from this relationship, is far from perfect. To verify the correlation does not depend on the units of measurement. Suppose that earnings had been reported in cents, in which case the sample standard deviation of earnings is 1,993 cents per hour, and the covariance between age and earnings is 9,151. Open units are years times cents per hour, close. Then the correlation is 9,151 over open 9.57 times 1,993 close equals 0.48 or 48%. Figure 3.3 gives additional examples of scatter plots and correlation. Figure 3.3a shows a strong positive linear relationship between these variables, and the sample correlation is 0.9. Figure 3.3b shows a strong negative relationship with a sample correlation of negative 0.8. Figure 3.3c shows a scatter plot with no evident relationship, and the sample correlation is 0. Figure 3.3d shows a clear relationship. As big X increases, big Y initially increases, but then decreases. Despite this discernible relationship between big X and big Y, the sample correlation is 0. The reason is that for these data, small values of big Y are associated with both large and small values of big X. This final example emphasizes an important point. The correlation coefficient is a measure of linear association. There is a relationship in figure 3.3d, but it is not linear. See figure 3.3. Scatter plots for four hypothetical data sets. A shows correlation of positive 0.9. B shows correlation of negative 0.8. C shows a correlation of 0.0. And D also shows correlation of 0.0, but it's quadratic. The text reads, these scatter plots in figures 3.3a and 3.3b show strong linear relationships between big X and big Y. In figure 3.3c, big X is independent of big Y, and the two variables are uncorrelated. In figure 3.3d, the two variables also are uncorrelated, even though they are related non-linearly.